or your idea here to set up the station this way?
Titans.
Titans.
So yeah, he was very specific about what he wanted, and I really liked what it did.
Yeah. So you're getting this tool set up.
Yeah, we're gonna go make some chips.
Okay. Cool. Oh, what's up, everybody? Hey, I'm over here. What's up? This is the most live design that I think we've ever had. This is the series that I was telling you, Barry. Like we started this during the very beginning of the pandemic. You know, initially just to give you guys some much needed respite in those crazy changing times.
Yeah,
but
get you guys out of the house.
Yeah, and like we've never really had like a very live design, you know, in person. But I'm super excited here to be with you, Barry.
Yeah, same here.
Barry Setzer here. So if you guys watched yesterday, we were on Manufacturing Live. So Barry, 3 others, talked manufacturing in a lot of different senses, like we often do, right on Manufacturing Live. But now I was saying to you yesterday, you know, when I first met you, like in person for the first time, known you for a couple years now.
Yeah.
It's just insane that we're just meeting all these different people after being on relative travel lockdown for
It
so
is
long.
funny. You know, feeling like you know somebody for so long and then you meet them for the first time. It's pretty weird.
Yeah, like I've seen you, right, the Champions meetups,
Yep.
SolidWorks Champions program. We've worked together just like talking like SolidWorks capabilities, stuff like that. Like I think we were talking like flow sim, SolidWorks simulation a little bit. They were talking to Matt Clegg yesterday about that. But no, it's crazy being here, and like also of course like I can't understate it at all. Being in this huge shop that I've seen on YouTube only.
Yeah, and it's like I said yesterday, you know, this is Disney World for machinists. We got top of the line machines, top of the line software, top of the line tools, and we got the best team in the industry, so it's really an amazing place to be.
You really walk in here and it's like, you know, we've all been, and a lot of us anyway, we've been in different shops, but this here, you know, we walked in at the end of the day, you know, I traveled in from the Philadelphia area, and you know, you walk in, and again, it's like some of it you might expect because you've seen it on YouTube, and like we've had meetings and stuff like that, but you get a sense it's like, man, you guys have crazy capability, and not only from the part creation standpoint, but also just like as a full-on like production facility.
Yeah, yep. We can absolutely make anything in the world here out of any material, so it's pretty amazing.
Yeah. And
it's one of the cleanest, nicest places too.
Yeah.
So.
You guys have like, even, you know, in terms of content creation, right, with the Academy, like taking, like you said yesterday, taking all the knowledge that you guys have built up over, I like the way you put it yesterday. It's like you guys have like careers worth of knowledge that you can put into, you know, a 5-10 minute video.
Yeah. We, you know, combined, we probably have 200 or 300 years of experience in the trades. So when we give you guys a little pointer, you know, it's from past experience, so something that's useful to you if you just bank it.
Yeah, and there's people watching, you know, I know people that follow you guys, Titans of CNC, people that follow us here at SolidWorks, maybe both.
Yeah, that's super cool.
You know, like it's funny because we geek out on even like computer hardware. You know, that's something that I know we all have in common. So for me, even like going into where you cut your videos, you know, seeing like the guys working in there. You know, seeing like all the stuff that Titan and the rest of you guys are doing on the machines, that was kind of a treat for me.
Oh yeah, that's where all the magic happens.
Yeah, absolutely. You were saying yesterday, like this is kind of like you see it as like the Disney World or the Disneyland for machinists.
Absolutely. I mean, where else can you come where you have this much experience and this much access to top of the line technology, and it's all for the sake of educating you guys out there?
Absolutely. Yeah, that's one of the coolest things. So we're going to talk tomorrow on SolidWorks Live. We'll be back, you and I, as well as some other guests, just about some new ways even that you guys are looking to really serve the audience with CNC Expert. I'm super excited about that. So I think we're going to get started in just a moment here. Yeah, we usually have, it's funny, like we were saying, on live designs, we usually have like these well, we just did like a walk and talk session, but it's just like you're kind of, you know, you're sitting in your home office or you're sitting in your shop.
It's virtual, yeah.
Miles apart. So it's awesome. We just got the 20-second, you know, we're about to start timer. So yeah, man, dude, I'm super excited about this episode.
Same here. This is gonna be so fun.
Yeah, like just being live, being actually around machines. Super excited. Well, hey, we're about to get started, right? So without further ado, you guys are watching Solidworks Live Design. We are going to show off some great capabilities for making aerospace parts in Solidworks. So let's get started.
Boom.
That was so funny. Just trying to make sure we don't trip, right? All right, so what are you going to be showing us here today?
So I'm going to show you a part that's super similar to a part that I've done in the past. And you know, it's going to take a look at some of the features of SolidWorks that you may not have thought about using in the way that I'm using them on this part. But I think it's extremely helpful to people in the aerospace industry. You know, a lot of people don't think about the fact that most of the planes in the sky today were built in the 60s, 70s, 80s, in times where 3D CAD really wasn't as mature as it is now. So a lot of the drawings that exist are one-to-one scale, hand-drawn things, you know, undimensioned drawings. And it can be tough sometimes when you have just a part that's pure contour. You know, how do you model that without taking a ton of points and measurements off of like a Mylar drawing?
Yeah. It's crazy. We've talked, you know, again, just most up until yesterday over Zoom, and you know, you'd show me some stuff that you'd created in the past, and I was just like, how do you even begin?
Oh yeah. I mean, some of the drawings, you know, we were looking at together, it's like these things are 20 pages long, you know, thousands and thousands of dimensions for a single part, and it can be pretty taxing, you know, when you first look at it, and your first instinct is like, oh, there's no way. But you know, if you take a structured approach to it, you know, you can get through anything.
For sure. But as we get started here, you guys at home, this is actually live. Like we call it live design. We're not kidding. So as you have questions, there's a reason why I have this tablet. You may even see me check in on my phone here. But if you have questions, you know, let us know. We'll be looking out in the chat.
Awesome.
Awesome.
So if you want to take a look at a typical aerospace drawing for a pure contoured part.
So you have all these sections here.
Yeah, you have all these sections, you know, there's very few dimensions. You know, they'll give you the 3 planes, so you get a waterline plane, which is the distance from the tarmac, you know, vertically. You get station planes that are going down the aircraft horizontally, and then you get butt line, which is from center of aircraft outward. So it gives you planes that kind of define where the part ends up in space. And then they give you a bunch of section views, you know, so you have all these section views, it's all curvature, so how do you model that, you know, without taking thousands of measurements for every little arc and stuff on this drawing? And I did a part that was very, very similar to this. I've probably done hundreds of parts that were similar to this. And, you know, in aircraft drawings, they will usually give you something to scale the drawing. So in this case, we have a grid, we have our station lines that are all 4 inches apart. So they gave us enough information to model this part, even though it's an undimensioned drawing.
It's crazy. It's interesting, you know, like some drawings that I've seen and some that you've showed me, you know, maybe, and you know, they're 40, 50 years old. It can be really hard, right? It's like I can't access that person that made that drawing initially. I wish I could. And there's so much abundance of crazy amounts of information.
Oh, dude. And you know, 50 years ago, the FAA had very different standards than what they have today. So, you know, there have been huge assemblies that I've modeled, and then you find out that none of the parts go together the way that they were drawn. And it's like, well, you know, how have you guys been building this aircraft for 50 years? And it's kind of neat because at some of these aircraft companies, you know, you can find people that worked there 50, 60 years ago that still work there. And I remember one time in particular, I was doing a main landing gear door assembly, and I went out to the shop and there was this guy that was still working in the hand forming section. And I said, hey man, you know, these parts don't go together. How do you guys make this work? And he's like, well, we've been hand trimming those ever since this drawing came out. And it's like, wow, okay.
Glad I caught you.
Oh, dude, and you know, that was probably the funniest thing for me getting into the aerospace industry was, you know, I expected to walk into this shop that was super high technology, you know, robots everywhere and crazy scanning equipment.
Sure.
And I walk in and it's just like a bunch of shoemakers elves, you know, they're all sitting at these tables and beating on a piece of sheet metal with a piece of rubber. And I was like, this is how airplanes are built?
Okay, I learned something today.
Yeah, and it really did require a completely different skill set. You know, I mean, interpreting these drawings can be difficult because it's parts on top of parts on top of parts. It's all one-to-one scale. You know, some aircraft companies have pretty amazing technology for being able to scan in the original Mylar drawings and stuff, but some of them don't. And so sometimes, you know, a company like Boeing or Northrop Grumman, they'll send you nothing but a photograph of the original Mylar drawing. So that's very similar to the case that we're looking at right now. You know, how do I go from a photograph of a drawing or a TIFF file or a JPEG and nothing else to a complete part or a aircraft forming tool to create a part?
Right.
And so one of the tools that I like to utilize for a drawing like this is sketch picture.
Okay.
So if we open up this part here, you know, you'll see that it's got pretty crazy contour to it.
Oh yeah.
I mean, it'd be very tough to model this unless you had like a point cloud or a bunch of loft data that you can use, but that drawing didn't have any of that.
For sure.
So if we take a look at our plan view, the very first thing that you have to do is get that drawing scaled perfectly. So we bring that picture in, but there's no telling if it's tiny now or if it's gigantic.
Sure.
So using these two dimensions that we had on the drawing, I just drew a sketch and dimensioned it and then scaled the drawing to match that. And you'll notice a lot of times like dimension lines on a drawing will be 2 pixels wide. So what I almost always do is go to the center of those 2 pixels, and that hasn't failed me in maybe 20 years of doing this.
Okay, that's interesting.
Yeah, so you'll see here we got our first scaled version of our sketch picture. All we did was we scaled it, and this is just going to be kind of a checking tool to make sure that we got the outer contour of our part correct.
So I noticed you have just a couple things from like a Solidworks standpoint. Like a lot of people, I like how you set this up, and you seem to be very organized. You know, like it's like all my planes, but even further, right? The system-defined planes, like the 3 you have right up top, like above the origin, like you rename them. So how are you? So you're taking? Are those dimensions you have there?
Those are the 3 planes as defined by the drawing. So if you look, station 121.5.
Yeah.
Whoops. That's going to be the station that defines the front end of our part. And then the same thing with the water line, 76.5. That's used in all the sections. And the same with the butt line is used in all the section views. So by naming those planes to follow the drawing convention, now we can mate those up in 3D space.
Okay, that makes sense.
And most people that model aircraft parts will do that. You know, they'll define the part in space where it ends up on the actual aircraft. And that's for saving time, you know, as you start building assemblies of an aircraft, you want to just drop it in.
Yeah, you drop it in.
You just drop it in and it's already in position. In this case, that's not as important because we're just doing a single part for the sake of building a hydroform tool.
It's probably one of those things, though, right, where you just kind of build it in. It's like, well, I have to orient this somewhere.
Yep.
Someone's going to do it the same way.
Yeah, and you might as well because you know there's no telling when down the line somebody else is going to use that model for something else.
Yeah.
And I've done that before, where I took shortcuts and just kind of threw something in space, and then later somebody's like, "Hey, why'd you do this?"
That's a great tip.
And, I did do things a couple different ways in this model just to kind of discuss the different options that you have. So if you take a look at, say, section NN here, I don't have any actual sketch in this sketch.
Just like a holding place for the sketch.
Right,
okay.
right. And a lot of times I prefer to do it that way because I don't want to accidentally change the scale of my sketch picture. So I'll create a sketch that only has the sketch picture in it to scale, and then I'll do another sketch later that has the actual contour geometry that I want to use.
That's really smart.
So you can see that each of our defined planes in the beginning line up to our station lines on the drawing. So for each section view now, we have a plane created that we can drop a new sketch picture on, and our section view of that particular station line. Now we start digging into the actual loft of the surface that we created. We can just take a look at all of these sketches. And you can see that for each section, we have a sketch.
Yeah, so are you grabbing, like, are you taking the detail views of the different sections?
Yep, so if you take a look at the sketch picture that's related to that sketch, you can see that I brought in another sketch picture, if I can figure out what view I'm in. And so for each section here, I have a different sketch picture.
Okay.
And so it's moved around in relationship to where the part ends up in space using that butt line 47.6 and 76.5 water line. So a lot of people, you know, they may end up using sketch picture for maybe one or two views of a part. With aircraft, you know, when you have a part that has 100 section views that are all undimensioned, you can bring in 100 sketch pictures and you can move them around however you need to. And it's really nice with aircraft that they give you those 3 planes to be able to orient things perfectly to your origin.
Yeah, you're right. Typically, like when I've used sketch pictures, I mean, there are a lot of cases where it can suffice, but you know, we can see it. We saw it especially at the very beginning, like the finished part, you know, without the sketch pictures and everything. Like you said, there's a lot of detail. You know, how the curvature changes along the different sections. It's super intricate. So that just that wouldn't suffice in this case. Right,
and with you know, with aircraft sheet metal parts, it's so easy to be able to do this because 9 times out of 10, the tolerance that they give you on these is like plus or minus 30 thousandths, and that's visually with an inspector laying the part on a Mylar. So, you know, if you're off by 1,000th or 5 thousandths or something, it's not going to kill you. And then you also have hand-forming departments, like I said, the little shoemaker's elves that come out with their little pieces of rubber and smack the sheet metal into shape.
Even that detail, like we talk a lot, like on other episodes of Live Design, about how, you know, insights on how to make something in SolidWorks, like those are always really useful, but getting like that career insight, you know, especially for someone who's like starting off in the trades, who may like, it's like you may have an idea of what an industry is like and how things get made. But yeah, oftentimes that doesn't match reality perfectly.
No, you might find out that you were completely wrong.
You might have been completely wrong.
And I mean, it's kind of funny when I think back to when I started my career in aerospace, because at the time, I thought I was good at SolidWorks, right? And then I got into this first place and come to find out that I had a lot to learn still. I mean, I wasn't very mature in my surfacing skills, and there was a lot left to learn. And so even today when somebody says, oh, you know, Barry, you're a SolidWorks champion, you know, you do all these complicated parts, and it's like, yeah, I would say that I am decent with SolidWorks, but I'll never say I'm good at it again.
It's hard to say that, right? It's hard to say that. Like we were talking about the Dunner-Kruger effect the other day. And you know, it's like when you first start off, right? It's like, yeah, like I got my CSWP, like I'm awesome. But then you have to start, you know, making things, different companies, different industries, and you get to see that there's such diversity in terms of how different parts are created, how different industries do things, different users, right, that have different techniques of doing things. Yeah, like we were talking before the stream started, and if you've gotten your CSWP surfacing certificate, give it +1 in the chat. You're saying that was like the hardest exam that we've ever taken, and even then, like I still feel like I could learn a ton more about surface modeling.
Absolutely, and like we mentioned before the stream started, you know, those certification exams are so good for teaching you things that you didn't know going into the exam. So you may fail an exam the first time you take it, but what you learned in there is so valuable later down the road that it's totally worth taking the exam.
Absolutely, for sure. And just a reminder for you guys, again, watching at home or at the office, any questions you guys have, like we are monitoring here on the stream, so we'll get those asked.
Yeah, feel free to ask away. I feel like there's several holes even within the aerospace industry for people that are capable of creating like aerospace forming tools, things like that. And that's something that I have done a ton of. I've probably created thousands of models for hydroform tools and coining dies and press brake tools, all the form aircraft sheet metal parts. And it's tough to find other people that know how to do that, you know. Even at some of the bigger aircraft companies I'll go to, and no one in their engineering department knows how to do it. You know, there may be one or two programmers that know how to do it. And so I kind of like to talk a little bit about that today, and get into a little bit of the surface modeling, you know, in addition to what we just did with sketch picture.
For sure.
So there's a few different things, you know, when it comes to lofted parts that you may get. You may get the undefined drawing like we just had, undimensioned. You may get loft data, which comes sometimes in the form of a book where it just has a bunch of XYZ coordinates and say vectors for angles and stuff. You may get hand-drawn overlapping lofts, like for things like the wing loft, where it looks like just a constantly decreasing teardrop shape. And you know, I've worked with every different type of loft data that aircraft uses. And
just here, Barry, before we move on from this part, because I was looking at some of the profiles that you had. So essentially what you're doing, like within the actual, like once you have, you know, the sketch picture and the different sketches, like as like a holding body. So that loft, that's comprised, what, of a bunch of splines?
Yep, a bunch of splines. There is a guide curve down the middle. So,
okay. So that's how it stays centered.
Yep. So if you take a look at, there we go.
There we go.
I think that's section N. So if you take a look at section N, that gives us the guide curve to kind of tie it all together. And then the individual sections. So all we did was create a lofted surface using that guide curve and these splines. And then from there we just thickened it, which it gives us on the main view of the part, or I think on one of the section views.
Cool. We got one of our user group leaders asked, so it's Steve Calvert. He said,
Steve.
How do you align the planes from the sketch picture?
By using the waterline, butt line, and station lines that are on the drawing. So that's kind of the reason that the original engineer gave you those, because you can use where they align, you know, centered here to your origin, which is exactly what I did. Let me hide some of these.
Isn't that great when we can prove that we're actually live? Can't fake that.
Oh, let's see here. Let's do section. Let's take this one. So if you take a look at where those two planes in our section view align, and again, we're using the center of the 2 pixels for the dimension line, you can see that our origin ends up being right there at the center of those 2 planes.
Gotcha, I see that.
Yep, so for our waterline and butt line direction, we're aligning it to the origin, and then we have a plane that's perfectly aligned to the station section view.
And then in terms of how you thicken this, so you're doing a loft, and then you said you have the guide curve right in the center, right?
Yep.
So in terms of how you thicken, are you thickening it, I guess, are you going both sides about the, or
no, what,
are you doing?
What I tend to do is I will pick either the upper contour or the lower contour.
Okay.
I kind of like to go one direction, and it's probably just personal preference, but usually when I'm creating a model like this, it's going to be for a forming tool, and so I kind of like to keep my part in one direction, then the lower die below that, and then the upper die above the part. So I don't know, it's just personal preference.
Personal preference. Cool. Yeah, this was awesome to see your approach.
Yeah, and this is something that, you know, you can use in more industries than just aircraft. Me and somebody were talking earlier about they've seen the same type of lofted drawing in the marine industry, and you know, I haven't done that much with shipbuilding, but it's useful elsewhere.
Yeah, it's something I know Matt Clay, he's roaming around here somewhere. He could probably tell us a bit about.
Yeah, he was actually who I was talking to.
Oh, so it's like, oh yeah, I got that from our little trip here.
Yeah.
Cool.
Yeah, and there's a lot of other things, you know, depending upon the available technology at the company that you work for, they have scanners that can take a Mylar drawing and scan it in, and then you can stretch it and go raster to vector it, and then you have sketches already. You'll have inspection departments that can take a roamer arm to an existing part or tool and give you, you know, a surface model, or take their Creaform scanner and scan stuff. But you may not always find yourself at a billion-dollar aircraft company that has all that technology.
You may not always.
And then a lot of times in a machine shop, you won't have access to that, you know, because your job is to make a specific part, and you get the bare minimum data that, you know, a lot of times that's all that's left is whatever they drew by hand 40, 50, 60 years ago. So
yeah,
it's good to just know all the available options to you and to know how to process each of these different types of loft data.
Absolutely.
Now, one that's always been kind of fun for me is working with point clouds.
Yeah.
You know, sometimes an inspector or an engineer will end up giving you way too much information. So, you know, whenever I have somebody scan something for me, I usually tell them, you know, if you give me a point spacing of like 1/8 of an inch, that's usually sufficient. You know, I don't need you to give me a point every 5,000ths, because that's going to give me this gargantuan file full of points
size
that
insane.
You know, you can't hardly see anything. So there was a part that I did for the Navy that's similar to this. That it was a similar situation.
Yeah, and this is something that comes up a lot too, right? It's like, yeah, across different industries. I've talked to so many different companies having to use point cloud data.
Yep.
It's a very, very common topic.
Yeah, and again, it's one of those things where when you get into it in the beginning, it can feel kind of overwhelming, because you look at this just crazy, it's like looking at the stars in the sky, right? Like, how do I connect the dots to make something real? And, you know, there's a few different approaches. The one thing I like to tell people is it's very helpful to have the actual part in your hand, because then you're able to take some dimensions to kind of verify what you think you're seeing in the point cloud. So, you know, you look at this, you can identify some structures, and you can see that, yeah, looks like we got some kind of rib here, another one here 90 degrees away from it. Looks like we're sitting on a square pedestal. And then there's these different layers. And what this part actually was a, oh, and I forget the type of additive technology, but it's where they basically weld up a part on a plate, and then you go in and finish machine it. So when I initially got this point cloud, it had a ton more points than what you see here. But because I had the part in front of me, I was able to verify that it was symmetrical. So the first thing I did was get rid of 3/4 of the points that were on screen. I didn't need them. All I needed was to take one quadrant.
Yep.
So that helped keep my file size down, helped kind of simplify what I was looking at. And then from there, you know, I was able to identify straight line features by looking at the part and by looking at the point cloud through different views. So as I did that, the first thing I started doing was creating planes. So, you know, I knew that the bottom of the plate was square, so I came in and started defining planes using those points. And if I show all of our planes here, you know, you can see between having the part and having the point cloud, I was able to kind of define where a lot of these planes were.
There's an interesting question in the chat. I think it was originally asked, it's by Steven here. So I think it was originally asked on the former part, but I think it's kind of a general practice question. So Steven says, fewer loft profiles and spline points can give a better surface quality, but you need the profiles to control the shape. How do you strike a balance? So it's an interesting question.
Yeah, now something that I learned in making impellers is using an odd number of points will usually give you the best results. So I try to keep the number of points to a minimum. You can do things like create arcs and then using those arcs create your spline, you know, use the arcs as construction geometry. That's a little bit more painstaking of a process. Usually with these lofted sheet metal shapes, you can get away with just using splines because, again, it's going to go through the hand form department. The little elves are going to get their hammers out and they're going to get it into shape. But you're right in your assessment, but I try to stick to the minimum number of odd points that I can get in a spline and get a reliable match to the contour of the drawing.
Yeah, for sure. I guess in certain terms, I guess depending on what you're doing, you know, I guess it's with lofts, like just in general, it's about trying to capture the unique profiles, right?
Yeah.
Along a transition.
Yeah.
So Bayram asks on this one, just while we're still here, can you show the loft parameters? I'm wondering about your tangent. Okay, so your tangency conditions. So let's do edit feature real quick to show that off. Okay, so merge tangent faces. Then I guess.
Yeah, nothing fancy. And I'll tell you one thing that was kind of funny for me in the beginning when it came to working with lofts. I didn't know what these little balls at the end were. So like I would get these weird twists in my loft, and I'd be like, "Why is it doing that?" I recall that too. And that was also like if a coworker would call you over and be like, "Why would this not work?" Like once you knew, it's like, oh, it's like, wow,
yeah,
I moved this little Pac-Man, and suddenly everything is beautiful.
Great.
Awesome.
My file isn't corrupt. That's cool. Awesome. So yeah, I think we're good to jump to the next one.
I saw a question that I actually liked, asking what my favorite surfacing feature is in SolidWorks. And this was another discussion that I had earlier today. There were two things that really just opened my mind when it came to surface modeling, or blew my mind, I should say. And that was when I found out that you could do copy surface with a distance of 0. And all of a sudden it turns into copy surface. Like I had no idea you could copy a surface.
It's like a cheat code.
Yeah, and that was so useful because there were a lot of times where I would be trying to like trim a bunch of surface bodies together, but maybe a couple of those faces were part of the same surface body. And then it's like, well, you can't extend me into myself or I'm self-intersecting. So you just create a copy of a surface, then hide the original face. Now you can, or delete the original face. Now show your copied surface, and now you can do whatever you want to it. Extend it into all the other surfaces and then trim it up.
Man, surface modeling, surface editing tools are just so cool.
and they're critical when you're doing things like aerospace parts and aerospace tools. The other thing was, when I realized why I was getting all these self-intersection errors, in the beginning, I didn't really know that a surface shouldn't intersect itself. So I would be trying to like figure out how to knit a single surface body to itself to create a solid. And that's another time where copy surface came in pretty handy. You just copy the surface and now you got something that you can knit together.
Yeah, right.
So copy surface, I think, is one of my favorite tools.
Yeah, it's one thing I mention a lot to people that are beginning SolidWorks or even any 3D modeling package. It's if you don't consider yourself needing to, let's say, make swoopy shapes, consumer products, that kind of stuff where you typically find surface modeling very inherent to a design, it's still a very useful tool to know how to, like a tool in your toolkit, right? Yeah. Even if you're doing mostly solid modeling.
That's right.
If you have imported parts, it's great.
Super big deal, and as a machinist, we do a lot of that. You may have a part that was modeled at the maximum tolerance or the minimum tolerance, but you want your model to be nominal so that you can apply tool path to it and get something that's going to be close to nominal when you actually machine it. So you may want to offset faces, you may want to change the size of a fillet, and surface tools all come in so handy for that. I see a question that actually makes me laugh from Scott Alley. He actually worked with me at one of my first aircraft companies. And yes, Scott, I do remember the first hydroform tool I did. And I'm pretty sure that Scott was there with me when I did that, and he probably taught me how to do it. So he is actually one of the few people in the country that I know that's capable of doing a really good hydroform tool.
That's
so
cool.
It's cool to see you, Scott.
Absolutely. Cool. I see Timothy Kraft asking best approaches to dimension splines.
Oh, that's a good question.
It is.
You know, to be honest, in a situation like this part, normally I'll just draw it and then fix it. Just because, you know, there's not a lot of
Just
dimensions.
make sure it doesn't move.
Yeah, just to make sure it doesn't move on me. If I was really, really concerned about it, I'd probably end up using ordinate dimensions to tie it all down. I love ordinate dimensioning. It's just so simple and easy. You know, it's just click, 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 click.
0, 10,
Yeah,
whatever.
Yeah. Yeah, but normally when you're working with splines, it's something that, you know, doesn't demand a gigantic amount of super accuracy, you know, so usually it's sufficient to fix it, but.
Cool. Well, hey, thank you guys for the questions. Keep them coming. Do you want to jump to the point cloud example, or do you want to?
Yeah, sure. We can go back to that.
Okay.
So you can see from here, you know, we got a bunch of planes defined, and using those planes now, we're going to start creating some solid features and some surface features. Show my solid body here.
And I love what you said, by the way, Barry, about like when you first jumped to this part about working with symmetry. There's so many areas where you can do that in modeling and running FEA. Right?
Oh, yes.
That's especially useful in cases where it's applicable and, you know, it's not going to tamper your results, what you're after.
Right, and as powerful as the software is, as powerful as your computer hardware may be,
yeah,
the smaller you can keep the file, the more efficient you're going to be, the faster you're going to get your models or, you know, analysis done. Roll back here. So you can see to start with, the first things I did was using my actual physical part, I created some solid boss features. So these were just the layers of weld that they had built up to kind of create this pyramid-like feature. So that was easy because I was just able to take out a pair of calipers, throw it on the part and say, okay, I know where these are, and I know what size they are. And then started to make some surfaces using the planes that we had already defined and some of the points that we had defined. So we built some surfaces for our base here. We built some surfaces for our rib.
So in terms of like using, in this case, like if you're using surface plane versus, you know, another guess that maybe how you could do this is just like making a plane there if you don't have one already, and then just like doing a sketch on the points. Yeah. Is there kind of a reason why, or is it just like I'm using surfacing tools, like I'm in a mode of putting the faces together?
I tend to get into modes. So
yeah.
You guys watching may have 100 different ways of doing what I did, and not any of those ways are wrong. If you ended up with the same outcome as I did, you did it right.
It's a good lesson.
Now some of us will get it done faster, some of us a little slower, but you know, the longer that you're in Solidworks, the faster you get.
Sure.
So there's a lot of little things that I do super fast, where if I was, you know, if someone was just starting our academy, say, I would not teach them to do it the way that I do it. I'd let the academy do its thing, because the way I do something makes sense in my weird, twisted brain, right? and in my experience. But, you know, for somebody just starting out, I may tell you to do it a completely different way.
Yeah. And we'll touch on the academy if you guys have time tomorrow. During SolidWorks Live, we'll spend a lot of time on the Titans of CNC Academy.
Yeah, so looking at this, you'll see, you know, I got one of the ribs modeled. After getting it to be a closed body, we knitted it together, created a solid. I knew this rib occurred in all 4 quadrants, so then we just did a circular pattern.
Cool.
Yep. Then we combined our solids, came in and finished off our base. And put a couple finishing touches on. We got our fillets.
Awesome.
So again, you know, this may not be perfectly accurate to within 1,000, but it was a welded up piece of material that was made to give us a piece of rough stock, so it was more than close enough for us to be able to machine our finished part from.
Sure. There's a couple of good questions here in the chat that just came in. So Mohammed asked, How do you deal with complex designs? This is a good one. Very, very general purpose too. Complex designs that need to be modified all the time, and every modification in every part of it affects the rest of the surfaces clearly. So I suppose what Mohammed's asking is like that case where there's tons of, based on the way it's been modeled, there's tons of potential downstream ramifications in your feature tree. And potentially, I guess, if we're talking especially about a surface model where, you know, we're patching together faces, and that could be difficult.
Yeah, so one of the things that I've done with some of my more complex models, and we're talking single part models that took me 6 months to create the model of, you know, thousands of features in the tree. And one of my favorite things to do is just save out a dumb solid and then bring it back in as an imported body, and now I can do whatever I want to it, and it's not going to affect anything from the past. So, you know, you can start cutting holes in it, you can start changing geometry, cut out chunks and change the loft between them.
We used to call it round tripping. I know a lot of people say that.
And I have a lot of models like that, yeah. I'll have a model that has, you know, 4,000 features in it. Then all of a sudden I'll have another one that has only 300, and you'll notice the very first feature in the tree is a imported body. So
yeah, and it makes sense. I mean, I guess it comes down to a simple question of like, what is it, like how is it serving, right? Because like you said, the rebuild time, it can ramp up, and our computers are getting better, the software's getting better. But if, you know, a history tree is there to be able to go back and edit, and if it's not serving in that purpose, then I'm not sure it's useful, right?
Yeah, you definitely lose something when you do that. I mean, the history tree is like the greatest invention of all time, you know, next to power trim. But
power trim.
Yeah. Sometimes you do have to sacrifice that for the sake of something that you want to do to the model that you know is going to affect downstream features.
Yep. And Thomas was asking, I think Thomas here. Thomas also from the Champions program. How's it going, Thomas?
What's up, Thomas?
I've not seen Thomas in years. Looking forward to seeing you soon. Could you reference those bosses to the points? Okay, so I think what Thomas might be asking is, it could be a different approach, right? If you're, for example, instead of, like if you're making like a straight on extrude for one of those sort of like more planar areas, could you do like up to vertex on the boss extrude?
Oh yeah, for sure.
That's something you could do.
For sure, and really initially building all those planes just kind of helped me to visualize the part. Because, you know, I didn't want to go in and start creating a bunch of surfaces right off the bat that I was going to have to trim later. As long as I was able to visualize what the part looked like kind of in the beginning, that's what I was after.
Yeah.
And so yeah, you're absolutely right. Even with the sketches of those bosses, I could have just done 3-point arcs using 3 points from the arc and then going up to vertex for the plane. So yeah, again, it's a case of having 1,000 different ways of achieving the same thing, and really it's just whatever makes you happy on that particular day.
Right, and whatever kind of gets you to wrap, like you were saying in the beginning, that's so important. Because I know, like when I watch, for example, you know, you going through this feature tree, or really anyone, right? It's like you go through, you review how someone built something, you have that power of hindsight, where it's like, okay, everything always made sense, right?
That's right.
But we all know it's like you have to, some of that early stuff is just like wrapping your mind around like, what's my workflow going to be like, because that starting point is so important.
Absolutely.
Yeah,
I'd say that's probably the most important 30 seconds of any model I've ever created, was the 30 seconds where I sit there and stare at whatever design data I've been given. So, you know, I will sit there and look at it, sometimes longer than 30 seconds, you know, sometimes it may be 30 minutes, but that is the most important time. And I can't tell you the number of times too that I have taken an incorrect left turn, you know, in the very beginning, and then later on I'm like, oh my gosh, why didn't I do this other way? But, you know, usually by then it's too late and you just move on. It's
funny, we don't really talk about that so much, and you know, we talk about, like, we have at our, you know, 3D Experience World, you know, we have the Model Mania competition where it's like fastest time wins, go, go,
yeah,
go.
That's so cool.
Yeah, it's super cool, and you know, it's a sport at this point. But yeah, like a lot of times, you know, when it's just you and it's this model that you have to create, it's very much that, right?
Yep. And it's actually almost harder the better you know the software, because now you have
so many
you have 1,000 different ways of doing it in your head, and it's like, you know, you may pick one that you're super comfortable with, but it may not have been the fastest route to the finished product.
Yeah. Thomas has another good question. It's on a bit of a different topic, but really on the point cloud topic, pretty generally. But, you know, what tools do you use, or kind of what sort of thinking, I guess, do you use to align the point cloud with the desired SolidWorks planes or coordinate system?
You know, honestly, I don't usually worry about that too much,
Okay.
because normally when I'm creating a 3D model, it's usually for the sake of machining something. So I'll create it in whatever orientation it's in. I'll create the model just wherever it is in space, but then I'll create a new reference coordinate system that I can save that model out using, and then it'll come in wherever I want it after that.
Yep.
So I make a lot of use of the reference geometry, what is it?
The
Coordinate system, yeah. So now, you know, if I create a coordinate system, just random location here,
Uh-huh.
and we'll say Z is this direction. And we'll give it an X too. When I go to save this out as, say, a step file or a parasolid, if we go into our options for, say, step file, you can now choose the coordinate system that you want that part to be saved out in. And that's really a pretty handy tool for those of us that are going to bring something in to be machined, because when we get into, you know, our CAM software, we want that part to land right where we want it to be and not have to translate it around. I prefer to use CAD for CAD functions and CAM for CAM functions, so.
Cool. And I think Thomas said, are your planes referencing the points or just dimension based on the physical sample?
The planes themselves are referencing points.
Okay.
So if you take a look at, say, this one here, that one happened to be using a face that I was perpendicular to, but the earlier planes
Sure.
are using points.
When that's
from the
all you
point
had
cloud. Yeah,
to reference, yeah.
That was all I had, so.
Gotcha. Cool.
Yeah, and it was a pretty cool part. You know, it's kind of neat seeing the way, you know, you have this one company give you this additively created part, then you have some other company that now gives you a point cloud of it, and then you end up with this chunk of metal on your desk, and now you need a 3D model that you can actually machine, and it's like, all right, well, here we go. I was reading a quote the other day from Nikola Tesla that said how Edison was the type of guy that if you told him he had to find a needle in a haystack, he would start picking up single pieces of hay and examining it until he found the needle. Well, it's kind of how point cloud modeling is. You know, you have to focus on the fact in the very beginning that this is going to take you a minute, and then you have to dedicate yourself to that process, and then, you know, in the end, you're left with a beautiful model that you can be proud of.
Yeah, it's weird. It's kind of like there's like a bit of like a mental like pruning process, right? It's like, because like you said, especially if you have a lot of points, it's like you have to sort of think about, you know, what is important, what's unique, what's important, and then, you know, how am I gonna use it?
Absolutely.
Let's see. Muhammad asks. This is just a pretty general question. This is like a manufacturing live style question, but how can you achieve the 3 requirements of good design at the same time? Achieving the work required of the design, the beautiful look, and the right price.
By committing yourself to all 3 of those. So fit, form, and function is one of the most important parts of a design part. So if it doesn't serve its fit, form, and function, it's useless right out the gate. So as far as I'm concerned, that is the most important thing. But second is cosmetic beauty. You know, if you're taking pride in making something perfect to the design data, you want it to look the part, right? I mean, I don't want something that I spent 40 hours on to look like a piece of junk. So I dedicate myself to making sure that whatever I machine is going to look as beautiful as the 3D model that I created. And what was the third one? Cost?
So it was, let's see, it's costs. So cost, I guess function and beauty. I think those are the 3.
Yeah, so cost is unfortunately probably one of the least important things. It's important to the customer, and it should be important to you, and especially in terms of being efficient. So you always want to try to get things done as fast as possible, but you also want it to serve its intended purpose and be beautiful. But, you know, if it's going to cost a little bit more for a part to look good, then as far as I'm concerned, that's money worth spending.
Yeah. It's funny, that was one of the first lessons I had. I think it was like my first job, it was my second job out of school. and there was a machinist. He had tons of, like, decades and decades of experience, and he said the same exact thing as you did just a moment ago. He said, you put so much time into getting this part right. Like, you want it to look beautiful. You just have it. It's a human thing, right? It's
right.
like, and you want to satisfy the customer or the,
yep.
the vendor.
Yeah, I laughed a lot
yeah.
in aerospace because, you know, not having burrs on a part is a big thing. And so I would make this beautiful machine part, we would deburr it in the machine, and then some guy at a deburr bench would come along with an orbital sander and just attack every face on it. And I was like, oh my God, what did you do? But yeah, you know, every industry has its own requirements, and a lot of those parts were going to be allodyed or, you know, painted after the fact anyway, but it still hurt my feelings as a craftsman.
Yeah. So let's see, just more questions. Thank you guys, really appreciate you asking all these questions. They've been great. Timothy Kraft, any tips on using the knitting tool, right?
Ah, it's another one of our usual buddies. What's up, Tim?
Yeah, and knitting tool, right, it's crucial.
Oh yeah,
when you're doing
absolutely.
surfacing.
And, you know, that kind of goes back to one of my two favorite features about surface modeling, is knowing that you need multiple surface bodies to be able to knit something together into a single solid. You're not going to knit one surface into itself. The copy surface tool, again, is another good one. You know, if this isn't a good example, but I'd say for knitting, just making sure that everything is trimmed together perfectly is a critical component of that. A lot of times, you know, you'll have just a tiny little corner of a surface that's interfering.
Right.
And, you know, Solidworks has gotten a lot better in the last few years. And there's been a few cases now where I'll have something like that and it'll fix it itself when I go to knit it. And that's made me very happy.
Yeah,
but,
that can be huge. Like, if there's like you're mentioning, the, you know, like the check tool, the imported geometry tool, especially if it's something where you're bringing in geometry, that can be maddening to a certain extent, right? If it's like, it looks fine, it looks great, right? So using those tools is fundamental.
And that brings up another two favorite features, is repair sketch and then geometry check. You know, like, without those two things, I would have spent countless hours trying to figure out what was wrong with something that I did. But, you know, like with knitting surfaces, I mentioned earlier how much I like copy surface. So here's something that I do a lot when I'm surface modeling, and it may seem kind of self-evident, but it really isn't unless you're used to creating surface models a lot. So within the surfacing workbench, we have offset surface. So say I wanted to get rid of this face and do something different, or, you know, there's no telling what I want to do with it, but I'll create an offset surface of that at an offset of 0. So now I have two identical faces on top of each other. I'll go hide that offset surface that I just created, and then go into delete face, get rid of the old face, and then I can show my offset surface. Now I have two separate surface bodies that I can now knit together to create a solid body. Back to a solid again. So it's kind of a cheat, and you know, there's a lot of specific cases where I'll use that little technique, but I can't think of an applicable one right now. But just keep that in your toolbox, and later you'll find a use for it if you're doing surface modeling, guarantee it.
Yeah, and a solid, right, just at a fundamental level, a solid's just a collection of surfaces, right? It's watertight, and it's considered together, it's filled in. But really, just an example like that, if you're not really used to surface modeling especially, like you said, there's a lot of use cases for that kind of thing, but, you know, it shows you what you're actually dealing with, right?
Yep, and how to use the specific tools that you want to get more familiar with.
It's interesting too, like, you know, the knit tool is sometimes important. It's sometimes important to use, and sometimes you have to use it. And even within some of the surfacing commands, right? They sort of have those like merge commands within them. You know, and that depends. I guess it depends on the person, because there's always an argument. There tends to be, you know, similar arguments with, you know, writing computer code, or if you're doing 3D modeling, where it's like, you know, how am I going to design this or make this, like, in its tree, its history, for editability later? Right. So like I prefer this, even if you could have done, and I don't think in this case you could have, but even if you could have done one of those, you know, surfacing, like additive surfacing commands or trimming commands to merge it, I just look for that surface knit feature in the tree, and that way I know, like, you know, how to go back to it and, you know, go before it or whatever I want to do.
Yeah, and again, it goes back to a lot of personal preference. You know, I think that when you're working with a team of engineers, it's important that you all kind of approach these things the same way. And so I think it's good to have standard practices within your team. But even with that, you're always going to have your own personality come through in your models. You know, I remember I was doing a lot of design for fire trucks, and one of the things that I used to like to do, because we all peer reviewed each other's structural models, is I would hide Star Wars models within my fire truck. And so I would take like R2-D2 and put them in the overwheel compartment, you know, and so the next engineer that's going through my model to check it, you know, he'd give me my peer review sheet back, and he'd say, like, remove R2-D2 from rear overwheel compartment.
It looks so serious when it's on the review,
does,
right?
Yeah, it was so funny. But, you know, I think it's important for your personality to show through in your work, you know, and it makes work fun.
Yep. Yeah, man. This is more of a question, I think, on the machining end. You know, but I think a very practical one. You know, when you go to machinist, when you put this in the whichever CAM software you're using, you know, do you want to go in with a solid, or can you leave it as a surface?
My personal preference is to always go in with a solid, and I tend to take it a step further, because I mentioned yesterday that, you know, I was a machinist to start with, but then I gravitated more towards engineering. And the thing I loved about, you know, 3D design was that I was able to model in every component, right? So I'd model in my vise, my raw stock, my finished part. I might even have several different stages of my finished part, you know, my first operation, second operation. So I like being able to visualize everything in a 3D environment. And honestly, you know, I've been pretty quick at creating programs for a CAM part. And I think part of the reason of that is because I'm utilizing a 3D model. Now, there are simple parts. You know, you may have a rectangle with 2 holes in it. You may not want to spend the time modeling that. But, you know, if you're doing a full 5-axis impeller, you definitely want to have some 3D CAD that you can drive through.
It's kind of based on detail preference.
Yeah.
Cool. Well, awesome. We're nearing the top of the hour. Again, you guys have asked phenomenal questions, so thank you not only for tuning in, but just making this show what it's been. I didn't know, Barry, if there's anything else you wanted to get into, or?
You know, I saw Timothy act about touching on the split tool.
Okay.
And, you know, mold tools probably isn't my strongest workbench, but I do use split for quite a few things, especially if I'm splitting a surface, trying to remove a portion of a surface. A good example, I don't know if you saw on Facebook the other day, oh, where do I have this hiding at? Figures. Oh well, can't find it, but it's extremely useful because you can use closed profiles to create a split feature, or you can just use single entities like a line. And so if we go back to, say, our sketch picture part, come on, you. One of the things that I like to use split feature for is if I'm doing engraving on a part.
Okay.
And what that allows me to do now is I have that line that I can follow in my CAM software, and it's at the same exact level as my surface. So it's not a cut that's going in, and it's not a boss that's coming out. So now I can control the depth of my engraving just using the CAM software and, you know, a ball end mill or whatever it is I want to use. So that's probably one of the things I use split tool for the most. Unless I'm getting into like designing hydroform tools where I am, one thing I do a lot is creating tooling tabs on the actual sheet metal part itself. So if we were to say do an offset surface, I'll come in and extend the end of the part by say an inch. And just another little pointer, usually before I start extending the surfaces of a part, I'll create a 3D sketch and then convert all the outside entities of that body. That way I have that to reference later. So as I start extending things, I still know where the edges of my original part were.
I love taking like those reference captures.
Yeah, me too. It's so useful. And so now out here, past the original end of the part, I'll create a tooling tab that can be used to put a tooling hole in for locating the sheet metal part to the forming tool. Close profile for that.
Cool.
So now that I have that face split off, I can just delete that face if I want, or whatever we want to do. But I end up having that tab that I can then put a hole in, and now follow the same shape of the surface. And
that's awesome.
Yeah,
they could do a lot of stuff with that. Super cool.
Yeah, so hopefully that answered some of your questions about split tool. It's not something that I use every day, but it's something that I've used a lot.
Yeah, absolutely. Awesome. I appreciate you asking that. All right, so we're about 2 minutes to the top of the hour. Yeah, I guess, Barry, anything else? I mean, we're good. You guys have asked, again, phenomenal questions.
Yeah, no, I'd say that, you know, as you start to play with tools that you're unfamiliar with, and as you start to get practice with them, you'll get faster and faster with SolidWorks. And that's something that I've taken a lot of pride in over my career, is being able to spit out models fast. And it usually helps the whole team. You know, if I'm on a team full of programmers, and, you know, usually we'll all have varying ranges of experience in different industries or in different software. And so if as a team you recognize each other's particular strengths and make use of those, then your whole team gets more efficient together. And so there's a lot of teams that I've worked on where I've been able to create a 3D model of a part faster than, say, half of the rest of the team. So whenever they need a complex model done, they'll hand it off to me. I'll knock the model out as fast as I can, and then, you know, they're able to work on something else that I was working on before. And so in that way, you know, you grow as a team. And I think SolidWorks is one of the most powerful tools I've used in my career. I remember when I first started using it, like, it blew my mind how much of a difference it made in my day-to-day work. And I've never forgotten it. I've never looked away from it, and I'm so happy to still be using it today. And it's even better now that I get to teach other people, you know, the tricks that we've learned through the years, and have such an awesome forum to be able to do it and answer live questions and just be a part of the amazing SolidWorks team.
Yeah, it's crazy. I'll tell the full story of how this partnership came together, because I still love to hear it, and I was part of it, but I'm sure you guys will too. And man, again, I just can't say it enough. It is so cool to be here. It's so cool to finally meet you in person.
Same here.
And yeah, and that's a perfect segue too, I think, to tomorrow. So guys, make sure you like, subscribe definitely to the channel. Keep up with what we're doing. We'll be back again tomorrow, same time, for SolidWorks Live. We'll talk more software. We'll talk a lot about the Titans of CNC Academy that Barry and the whole team here is obviously a huge part of. I'll talk some manufacturing software stuff. We'll also be dropping some news, some announcements on a new service that you guys have here called CNC Expert. So
super exciting.
Man, it's just so cool. You guys are on like the cutting room floor of like everything. I swear.
That's Titan's vision for you right there. He doesn't think small.
No, I've learned that in my calls with Titan. So once again, Barry.
Yep. Thanks so much. Appreciate it.
You'll be back tomorrow.
Yep. See you guys then.
Yeah, we'll see you then. Thank you guys.